Hey everyone, this is my Physics 2 Lab 3 magnetic field of a bar magnet. So the purpose of this lab was to visualize magnetic fields and observe the relationship between distance and magnitude of a magnetic field, and also to measure the distance dependence of magnetic fields. So some models and fundamental physical principles that we used were the Biot-Savart law and the distance dependence formula of a bar magnet. And the main lab result, from my experiment, I got an N value of negative 3.003 and then a mu of 3.88 ampere meters squared. And then my experimental and computational model of the magnetic fields had different values. So some physics principles that we used the Biot-Savart law. We used distance dependence formula, where K is a constant. And then the model below that is just taking the log of both sides. And then we also use the magnetic field of a dipole on axis. So the system and surroundings of this experiment, the system was the bar magnet while the surroundings was everything else. And then the initial conditions for the experiment was just like a bar magnet at the end of a meter stick. So the actual experiment, we used a magnetometer sensor in the phone. We found that by sliding the phone perpendicular to a horizontal meter stick with the bar magnet at the end of the meter stick, and then the on-axis magnetic field of the bar magnet was found by holding the phone at different distances along the horizontal meter stick. And then the distances were recorded for different values of the x component of the magnetic field. And then the perp axis magnetic field of the bar magnet was found by holding the phone along the horizontal meter stick, so that the x component of the magnetic field was 100 microteslas, and then moving the same d perp distance vertically. So this is just all of our data compiled onto the spreadsheet, and you can see that it outputted a equation for the line. And then this information down here is the off field, or the off axis field. So when we did like this perpendicular magnetic field test. So when calculating mu, we had to set the distance dependence formula equal to the magnetic field on axis to solve for mu. And then from the graph, we found that N is the slope of the line, and then K is the y-intercept. So we had to take the e of both sides to get K. Or K is not the y-intercept, but we use that to get K. And then we solve for mu using this formula. In the computational model, we had to split into 2 on axis and then 4 perpendicular axis. And then we have different, up here we solve for the magnetic dipole using R mag and then R hat. And then here's just the output of the computational model. And then here is the magnitude of B, the magnetic field, at distance D. And you'll see that that is different from the experimental magnetic field, which was about 5.949 times 10 to the negative 5 Tesla. While in the computational model, it was 7.201 times 10 to the negative 7 Tesla, which differs by several decimal places, obviously. So some possible sources of error could just be incorrectly finding the magnetometer in the phone, or not positioning the phone in the right orientation relative to the magnet, and then just coding mistakes while working on the computational model. So in the discussion, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid your meter stick at some intermediate angle with respect to the Earth's magnetic field? So this would have caused the measured magnetic field to be inaccurate due to interference by Earth's magnetic field. And this interference would likely result in a greater magnetic field, and Earth's magnetic field would have to be subtracted from the net field. And then what if we were to stick 2 identical magnets together end to end and run the experiment again? The collected measurements would likely have doubled or just increased, but the direction of the magnetic field would remain the same. So in conclusion, bar magnets can be used to bar magnets can be used to model magnetic dipoles. And then when determining the strength of a magnetic field, distance is an important consideration. Thank you.